So, have you ever wondered what happens in that tiny fraction of a second, that single microsecond, right before a nuclear bomb goes off? Well, it's not just one big boom. It's this incredibly precise, perfectly engineered cascade of events. And that's what we're going to do today. We're going to take apart an implosion-type nuclear device piece by piece from the inside out to really get a handle on its, honestly, terrifying precision. I mean, think about it for a second. It's a crazy question, right? How can a chunk of material, something small enough you could basically hold in your hands, release enough raw energy to just wipe an entire city off the map? That's the big question here, and we're going to break down every single piece of how that actually happens. All right, so here's how we're going to tackle this. We've got 6 parts. We'll start right at the heart of the bomb, with the core. Then look at its protective layers and the explosives that kick everything off. After that, we'll follow the sequence from drop to detonation, see how the chain reaction begins, and then, well, the result.
Okay, first up, the heart of the bomb. We're going to start this teardown right at the very center of the device.
So, right at the absolute center, you've got 2 key things. First, this tiny little sphere called the neutron initiator. It's a mix of polonium and beryllium. You can basically think of it as the matchstick that's going to light the fire. And then, wrapped all around that, you have the fuel itself, a solid sphere of plutonium. This is the real heart of the whole device. Now, that word fissile material is super important here. All it means is that plutonium is a material whose atoms can be split apart, and when they do, they start a chain reaction. But here's the catch. Just sitting there, plutonium is actually pretty stable. To get that massive energy release, you have to force it into what's called a critical state. And what does that mean? It means you have to compress it, squeeze it so incredibly hard and so densely that the chain reaction can't be stopped. Honestly, the entire bomb is just a super complex machine designed to do one thing: create that one incredibly violent squeeze. All right, moving outward from the core, you've got these different layers, these shells wrapped around it. And what's really amazing is they're not just there for protection. No way. They're actually active players in this whole process, designed to contain and perfectly shape the explosion that's about to happen. Okay, so what are these layers? Right outside the plutonium, you've got a shell of uranium-238. Its job is to act like a tamper. It basically reflects neutrons back into the core and holds everything together for just a few extra crucial microseconds. Next up is a boron plastic shell. This one's a safety feature, really. It soaks up any stray neutrons to make sure the bomb doesn't go off too early. And then, wrapping all of that up is a thick aluminum casing, which is the main body of the device. And this brings us to one of the wildest parts of this whole design. It's kind of a paradox, really. To set off this unbelievably powerful nuclear explosion, you first need a perfectly synchronized, regular explosion, a conventional one. So, packed all around that aluminum casing is this big sphere made of very carefully shaped explosive lenses. We're talking a mix of RDX and TNT. And then, embedded all over the surface of these explosives are dozens of electronic detonators. These are like the super high-speed spark plugs that are going to kick this whole thing off. Okay, so we've seen all the pieces of the puzzle. Now let's put it all together and see how it works. From the second this thing is dropped, a chain of events starts, and it happens with just breathtaking speed and accuracy. So the bomb is falling. On board, there's a radar constantly measuring how high it is. Then, at the exact right altitude, the firing circuit gets the signal, and bam, it instantly unleashes this huge electrical charge from some capacitors, sending a massive surge of power to every single one of those detonators, all at the exact same time. And we're talking about a 5,000-volt jolt. That's how much power it takes to make absolutely sure every detonator fires in perfect unison down to the microsecond. I mean, if they're even a tiny bit out of sync, the whole implosion just fails. It won't work. Okay, this is it. This is the moment of truth. This is where chemistry violently passes the baton to physics. That conventional explosion we talked about, it has one job and one job only: to kickstart the nuclear reaction by creating an absolutely unimaginable amount of compression. So here's what happens. First, the detonators all fire at once, setting off the explosives. This creates this perfectly symmetrical shock wave that just races inwards. This wave of pure force smashes through the outer layers and just slams into the plutonium core, squeezing it with unbelievable pressure. This massive squeeze does 2 things at once. It forces the plutonium into that critical state we talked about, and it crushes the initiator at the center, making it release a burst of neutrons. And now those neutrons are trapped. They have nowhere to go except straight into that supercompressed plutonium. And that's it. The chain reaction kicks off. So let's just hammer this point home. Critical state is all about one thing: density. That whole incredibly violent implosion has one single purpose: to crush those plutonium atoms so close together that a runaway chain reaction isn't just likely, it's guaranteed. It's a really stunning piece of engineering, all focused on this one single destructive goal.
So all of that incredible engineering, the different layers, the electronics, the conventional explosives, it all builds up to one final and frankly terrifying result.
And the result is absolute. The chain reaction unleashes a mind-boggling amount of energy in just a fraction of a second. That whole complex machine we just deconstructed, it's gone, vaporized. Its entire purpose was fulfilled in that instant, to unleash a power strong enough to just erase a city from existence. You know, when you step back and look at it, the whole thing is a huge paradox. It took some of the smartest people in the world to figure out how to create this perfectly symmetrical, flawless implosion. And it really makes you think, doesn't it? When we as a species get so good at understanding the fundamental physics of the universe, what does it say when we use that knowledge to engineer something for perfect, instantaneous destruction?